This is on statics. Okay? So the topic is all about friction. Now I'm going to share my screen. Right. So I hope you are all there. If not, yes, I just have to go through whatever I have prepared because I am worried you don't know anything about what I'm going to discuss, and this was given in the midterm exam. Hang on. Wala pa ba yung ano, sandali lang iho. Kasi naka-live ako ngayon. Sandali. Hindi pa ba ako naka-live dyan? Paki-check nga, naka-live na ako. Bakit wala? Wala sa ano ko, live ko. Hindi ko nakikita dito. Ang live stream ko. Can you see it? Sandali, let me check. Sa YouTube. Wala naman. No, resume. Hang on, I'll just check dito sa laptop ko na lang. Okay? Naka-live na ako. Sandali, naka-share yung screen ko. It's okay. Not a problem. You don't need to hide anything. Medyo mabagal nga lang, no? Sandali lang. Your videos. I-skip nyo na lang ito if you like to go to the topic straight away. Kasi, i-check ko lang kung okay na ang live ko. Alright, naka-live na talaga ako. Ayun. Yung link. Yeah. Sandali lang. Oh, I still have to pass the link pala. Hang on. Started stream. Yeah. So I have already started. I have already started the live stream, but I don't think. Yeah, it's working. It's working. It's wonderful, mommy Debs. Hang on, I still have to forward to you the statics one. Hang on, that is the statics. I'm busy. Naka-live ako pero oh dear, I still have to send everything pala. Static I. Who was the one? Okay. Right. Sandali lang. Who else? May statics ba sila? Wala. Yung may differential equation siguro. Who else? Hang on. I haven't started yet kasi I need to pass the word to. This is statics now. Ongoing. Okay, who else? This one. All right, I think I'm okay now. So let's resume. Where am I? Here we go. All right, mag-resume na ako. Sorry, you can skip this part if you want to. Right, so we now move on to the topic friction. There. What is friction? Friction is when you go against a force, and that force that is going against it is a force that is parallel to a plane, or anything that would go against um, a force that is pulling or pushing an object. So an example is, say you have a body here and it's lying on a plane, and there's a force that will pull it. The force that will go against the F is the frictional force. Okay? Now, if you're going to sum forces along X and equate it to 0, then the F here should be equal to the frictional force. The frictional force formula is given by mu times N. The N is always the normal force. Where is it located? Pag sinabing normal, then this is perpendicular to the body. So of course the body has got a weight, and the normal force is always perpendicular to your plane. That is the N. Always yan. Okay? At ang formula natin ay always na mu times N. Mu is the coefficient of friction. It depends on the material to which the body is lying down or resting. So when it's resting on a rough surface, it depends on the surface. Is it rock? Is it steel? Is it cement? Is it... Lahat yan, meron na siyang mga values ng mu. This is mu. You're going to pronounce it as mu, okay? Like a cat. Mew. Mu. There. So mu is always the variable that we use, or the symbol that we use for coefficient, which is in in EDA, you call it EDA or EDA. That is the mean or average. Okay, for those who are taking up statics now, they don't have their EDA. Right. There are so many disturbing sounds. So let's take up the system of blocks, because in my topic and in the question I had given in the exam, it's all about system of blocks in friction. Now, all surfaces, as you can see here, the mu is 0.2. But we need to put in some weights. So if you look at the figure, we're going to find the value of W. Okay, so let's put on some weights in each of the blocks. Block 1 will have a weight of, say, 10 newtons. Block 2, the weight is of course going down all the time. Say this is 5 newtons. Block 3 is, say 5 newtons again. What could be the weight? All right. This is a bit long. The one I've given you is a bit is shorter, but it has the same system. And block B is on an inclined, where the angle of inclination is 30 degrees. B3 is in a rough surface with a coefficient of friction of 0.2. Same with B1. Coefficient of friction is 0.2. Now, they are connected around pulleys. This pulleys doesn't have any friction at the moment. Okay, they are frictionless pulleys. If you say frictionless, then they will not stop the movement of the strings or the cables that are connected to the boxes. Instead, they are just like a medium for the pulley to roll, and it's helping the pulleys to be moving from one point to the other, or one direction to the other. Of course, there's only one direction, going up or down. Two directions, I mean, going up or down, or left or right. Yeah. All right. So this is what we're going to analyze. Let's start the analysis. Don't forget that what we're looking for here is the W. What is the weight of the block? Okay, that is in the system, the last block. Now, given this kind of system, you have to start from the first one, block 1. So you have to isolate block 1. Let's isolate. I will make it thicker in size. So isolate block B1, or isolate B1 in short. So you have here block B1. What are the forces acting? One force that is acting here is the tension on the cord. Of course, there's a string there that is being pulled so that B1 moves to where the weight is. So that is the tension on the cord. Let's call it T. The tensions here will be the same throughout. Okay? The T here is the same as the T there, is the same as T here, is the same as T there, is the same as T there. They're all tensions. However, there will be an effect of the T's as they are in different surfaces. And the T will also have an impact on the inclination and the mu, or the kind of surface where the blocks are. So T is one of the forces. We also have 10 newtons here as the weight of block 1. Now, friction will come to play. Okay, so you have here a normal force N, and because the line of action is going, I will put an A there. The line of action, A is acceleration. The line of action is going to the right, so your F must go left. I repeat, when the motion is going right, then your motion must go, when the motion is going right, then your friction must go left. Let me just check this operation manual B. Okay, we are not there. Okay, we are not there. Okay, so having set all your forces, I repeat, because there's a disturbance, you have a tension of the cord when you're going to isolate block B1. Here, isolate block B1. There. So you have the tension on the cord, you have the weight. The weight should be counteracted by your normal force N, which is always perpendicular to the plane. And then perpendicular means it makes 90 degrees with the horizontal. And then the frictional force that will go against the motion. What you're going to do here is to, because we are in statics, so you're going to sum forces along the X and equate it to 0. Okay? So what are the forces going to the right? Because that is our assumption. You have a T going to the right, nothing more. And then to the left, you have frictional force minus the frictional force is equal to 0. So the tension on the cord here on block 1 is the frictional force. Now, the frictional force is mu times N. Mu times N. What is the mu given in all surfaces? That is 0.2. And the normal force will be the summation of forces vertical. Okay, so let that be as one of our equations. Now, next thing for us to do is to solve for n. Okay, we already had used summation forces x. This is very arranged calculations because the first thing you have to do is summation of forces horizontal. Next is summation of forces vertical. Okay, summation forces vertical, or y, is equal to 0, upward positive. That's the first one. And the second one is summation forces vertical. What are they? Going up, positive. So normal force is going up. 10 newtons is going down. Minus 10 is equal to 0. Therefore, N here is equal to 10 newtons. So you substitute that in 1. Let's go back there. So that will be 0.2 times 10. Then that will just be 20. Or 2, sorry for that. 2 newtons. Okay, let's calculate. 0.2 times 10, then you get 2. Okay. So the tension of the cord is 2, and we are right with its direction. Its direction is going to the right. Okay. Tension here is going to the right. If you say tension, it's always going away from the body. So our tension here is going to the right. Okay. Now when it goes to the next block, then it must be on the other direction. So we are done with B. We now move on to B1, we now move on to B2. So for B2, here you go. I just have cut it. For B2, you have to isolate. We are going to cut it here and cut it here. Okay. So in this case, you have a lot of things to do here. What are they? Well, you have, I'll make it bigger. There you go. You have 2 tensions in your cord. There is one T here and there's another T here. Okay, so I will call this as the T a while ago from B1, which is 2 newtons. And maybe I can call this one a T2. Right? As I've said a while ago, it can be called all T's. However, you cannot say that the T2 here is the same as T on the other side or T1 on the other side. Why? Because the T has something to do with the inclination, with friction, and so on. Okay, so what is the line of action here? The line of action is going to the right. Letter or B2 is a bit confusing if you can understand it well. Let's draw the rotated axis. Okay, so that is our x, rotated x. I will call it x prime, and this is my y prime. Okay, what are the forces acting? I have my weight going down of 5 newtons, and because it had rotated, the axis had been rotated, then the y which was originally like this, vertical, it had rotated in this axis, So what is the angle of rotation? It's 30 degrees because your plane here had been rotated too. Let's remove that meantime. We don't need that. Okay, so here is your angle 30 degrees. right? Because the horizontal had been rotated 30, the vertical should be rotated 30 as well, because the x and y always together, they are always going together, and they're always in perpendicular arrangement all the time. The x and the y axis, they're always perpendicular to each other. Okay, so what are the other forces acting apart from the weight? We have the normal force. The normal force is here. And the action, line of action is going to the right. So the frictional force will be like this. I think it's better for me to change the colors. Okay. I'll use, say, purple. Purple for the normal force. The normal force is always perpendicular to the plane. So this is in. And then you have the line of action. Going to the right is our line of action. So frictional force must be going to the left. We're going to summarize all these forces in our presentation. Okay, so frictional force is over here. What more? The normal force in purple is over here. What more? We have T1. Our T1, I will use black for that. T1 is our 2 newtons. And then we have T2 over here. There you go. Let's check. Have I included the weight? Yes, I did. T1, 2 newtons? Yes, I did. T2, we do not know that? Yes, I did. The normal force? Yes, I did. Frictional force? Yes, I did. Very good. So all these forces are already in our system. So all you need to do is to analyze this system here. Okay. Now, because weight, the 5 newtons, is not aligned with our x prime and y prime axis, then we have to resolve the 5 newtons into its x and y equivalent. There is no problem with F because it's aligned. There's no problem with T2, it's aligned. N is aligned with the rotated axis, 2 is aligned, but 5 newtons is not. Okay, so what should we do? We have to align it as well with the rest of the forces. So here you go. I need gray for that. Right. So our Vn, I will put the Vn here. Our Vn, oh, it's not Vn. Our 5 newtons, this is on the x-axis, 5 cosine 30. This is our 5y. Okay. Our 5x will be 5 sine 30. This is our 5x. Bakit? Kasi our 5n is vertical. It's not aligned with our x prime and y prime axis. Okay? So ngayon, dahil ang adjacent side ng ating Vn, look, if I'm going to do like this is our, why am I saying Vn to 5n or 5 newtons? And this is our 30 degrees. Ito is the 5 cosine 30 degrees. And then ito, kung saan tinutumbok ng ating angle, is our 5n sine 30. I hope this is clear. That's why ang 5n natin sa x-axis natin, rotated x-axis, is this one. And our vertical component is 5 cosine 30, which is representing our 5y. All right. I hope that's clear. So we can now proceed with the summation of forces X and Y, but these will be rotated. Okay, so we are ready, and here we go. I want the blue that is like that. Okay, there are only two formula that we are using. Summation of forces. Please go to my YouTube channel, Wonderful Mommy Debs, DEBZ, for those who are watching here and the Facebook, because you can only hear me from here, but you cannot see my window. So this is my working window in YouTube. You can see it when you get there inside my channel. So you can see what I'm writing. Right, summation of forces along the x-axis, but this is the x prime, equated to 0, to the right positive. What are the forces acting? Of course, we have our T2. Okay, we have our T2 to the right. And then for the frictional force, it's going to the left. So that will be a minus frictional force. And then we have what more? We have the 2n minus 2n because it goes left. And then we have the 5 sine 30. So that's minus 5 sine 30 is equal to 0. That's all for the x for now. Okay? Now, for the summation of forces along y and equate it to 0, upward positive, let's see what we have in here. Let's remove all the excess muna and give emphasis to the forces along the vertical. And these are the ones. You have n and the 5 cosine 30. So you have upward is n minus 5 cosine 30 is equal to 0 along the vertical. Okay, I am slashing that one because I'm slashing my 0 to say that that is a 0. So, but in civil engineering, the 0 like this with a slash, this is a diameter actually. That is a symbol for diameter. But in computer engineering, then that is 0, right? Or in IT. Oh, where am I now? Right. Now, there are only two formula that you're going to use in here. There's no moment whatsoever. Okay? Now, why did I use summation forces vertical? Because I want to know the normal force. That is 5 cosine 30. And this will be substituted to my friction. So let's calculate that one. You have 5 times cosine 30. Oh my God. Oh, I'm not in radian. I'm not in degree. Hang on. Shift mode. I must be in degree because this is in radian mode. Now I'm in degree mode. So 5 times cosine 30. Be sure that you are in degree mode when you're using degrees like 30 and all. But if you're using like pi, then you can be in radian mode. 5 squared of 3 over 2. That is simply 4.330. 4.330 is that is in newtons. This is our normal force. And we're going to substitute this one to our frictional force in here. Okay, so let's continue. I'll change my pen to red because we're now going to substitute. Okay, we don't know T2 here at the moment. What happened there? Right, we don't know T2. Our frictional force is mu times n. Frictional force is mu times n, and all surfaces is 0.2, and n is 4.330 minus 2 newtons. I will not put the n anymore because that might be misunderstood na normal force siya, minus 5 sine 30. I think this is 2.5, but I just have to show you the calculation. 5 sine 30 equals 5, yeah, it's 2.5 because sine 30 is 0.5 actually. So that will be 2.5 is equal to 0. As you can see here, is only T2 that we need to know. I will tell you later why are we so interested with the forces on the strings or on the cable. Right, let's do the calculation here. It seems that all the values will be transposed to the other side. Yeah, because these are all negatives. Look, this is negative, transposed to the other side is positive, transposed to the other side positive, transposed to the other side is positive. So simply adding all this together so that you can get T2. And I think the answer will be positive, so we are ready to calculate, and we are sure that T2 will be positive. The direction is correct. Okay, let's start from the first one. 0. 0.2, sorry, 0. 0.2 times 4.330 is equal to, okay, and then I'm gonna minus 2. I'm gonna minus 2.5. Oh, why did I do that? Oh, that is silly. It should be plus 2 plus 2.5, right? Hey, 2.5 equals. So the answer is 5.366. 5.366 newtons. So that is the value in T2. Why did I add all of them? Because in simple terms, T2 will be moved to the other side, or all these constants here will be moved to the other side. So T2 will be equal to plus 0.2, 4.330 plus 2 plus 2.5. So T2 will give you 5.33, 5.366. Okay, so we're done with B2. All right. Now, why are we so interested with the cables? Because when you will isolate the weight in here, the weight will have this free body diagram, FBD. The weight is going down, and the one that is pulling it up, or the one that is um, making it static on its position, is the cable here, the T here. So if we know the T, then we know the weight by virtue of summation of forces along the y-axis. So that's the reason why we are interested with the T. Now, we are done with B2. The next thing we're going to isolate will be our B3, and we are near to the answer, what we're looking for. There, we're going to isolate that. I hope you are all there, and I'm not requiring everybody to be present in this video, but I just made it live so it will be recorded automatically, and I can just share it and then you can view it, because I just don't like to record like I'm the one only talking. I must have an audience, because that could be silly for me to do. Oh, that's too thick. Hang on. Right, here you go. That's too thick. I think that's better. Okay, so now we are going to isolate the third block. And what are the forces acting here? Right, I will use gray. What are the forces acting? Of course, you have the T2. This came from B2 block. It's 5 point. Let's have a pip. Let's have a pip. What was it? It's 5.366. Okay, let's go back there. 5.366. And now you have an unknown t here. I'm going to use blue for that. And this t would give you the answer after. So this T3 will give the answer of what the weight is. All right. So anyway, let's analyze first what are the forces acting in this FBD. The line of action is going to the right. So automatically your frictional force must go against the motion. Right. We are not yet in dynamics, but because we are assuming that the forces acting on this system will be all equal to zero, then in the event that there is motion, when there will be excess of forces acting on the left, acting on the x-axis or on the y-axis, then there will be motion, right? So now we are assuming that that motion is zero, but we can use that calculation to solve for unknown forces. Okay, so line of action is going to the right, so the frictional force goes left. And what other forces acting here? If there's a frictional force, there must be a normal force, normal to the plane all the time. Let me just say that again. If the body you're analyzing is along an inclined plane, then your N is always perpendicular to the plane. And if the motion is going right, then your frictional force goes against it. If there's a weight, then the weight is vertically down. It seems that the weight is inclined, but no, we rotated our x and we rotated our y. We are calling that y prime and we are calling that x prime. And this is the weight. Okay. In this case, you must resolve your weight on its wx and resolve the wy of your weight as well. So these are the forces acting. Okay. Now, it depends on where your body is acting. Yeah. If it's acting along the vertical or acting along the horizontal. Okay. So now it's acting on the horizontal. These are the only forces that we have. What are they? Let's see. Let's sum forces along the x-axis. Summation of forces along x. This is the actually second to the last part. Is equal to zero. To the right, positive. What are the forces? Of course, you have your T3, which will be our basis to find for W. You have T3, what's happening to my pin. We have T3 to the right, positive. What more? We have frictional force going against the motion, so that's a minus frictional force. We have minus T2, or I'll directly write 5.366. That's what we got a while ago in newtons. There are only three forces along the x. We have that and we have this one. And we have plot them properly and correctly. That is equated to zero because we are in statics, aren't we? Of course. Next semester will be your dynamics. There you go. Okay, so now we are ready for frictional force. But frictional force, however, frictional force is equal to mu times n. And n can be calculated from summation of forces along y and equated to zero as well, upward positive. Okay, so it's always like that. I am repeating for from the top for 10,000 times. This is my 10,000 one. So first is the summation forces along x, summation forces along y after. Okay. Now, why do we need to do summation forces along y? Because we need to know our n. Okay. So this is our n. Let's do it. So what are the forces acting along our y? We have the 5 newtons downward, and we have 5 newtons upward, because our sign convention is uh, going upward positive. So that will be N minus 5 newtons is equal to 0, or you have N is equal to 5. Knowing N is equal to 5, you can now go back here, substitute your mu equal to 2 and your N equal to 5, and you get a frictional force equal to 1. 0.2 times 5 equals 1. Okay, you can do it in your head, but I just want to use, of course, my downloaded Casio for demonstration. So this will be 1 Newton. Okay, there you go. Right. So we know the frictional force. We don't need the normal force anymore. So let's go back to where that T3 is, and let's substitute values. Okay, here we go. So T3 is here. My God. Okay, it's a slow. T3 is here, minus frictional force of 1. I'm substituting it here. Minus 5.366 is equal to 0. Now, you are interested of T3, so that will be 5.366 plus 1, because you have to transpose it to the other side of the equation. So this will now be 6.366 newtons. And that is the force and the tension that is holding your W in its position. All right, so that's it. Now let's erase this one here. Let's rub this off. By the way, I'm going to send this lecture as well in your GC. Right, so now we'll go back to where we have started. There. We have isolated our B1 check, our B2 check, our B3 check. Now we are going to isolate our weight. There you go. Our weight is to be isolated, and that will be the last part of our Hey, I have to go down here. Why is it taking that long? You know, when my laptop is saturated with a lot of writings, then the tendency is, hey, look at that. Do I still need that one? No more. See? Okay, let's go down very quickly, because I know that you want to finish this off now. Okay, so we were there a while ago. I'll just have to draw it because it's easier to draw rather than copying. So let's connect our system from T3. So it was like this. There's a frictionless pulley here, and this is block 3. And this is actually your T3. Why T3? Because the pulley is frictionless, so whatever is the force that you had computed from here, that will be also the force that is trying to put that weight in its position. There you go. So if we're going to isolate the last block, this one, if you're going to isolate that, so you have T3 here. Tension is always away from the body. It can never be compressive. Tension nga eh. Okay? So this is the weight. So summation of forces vertical is equal to 0, upward positive. You have T3 minus W is equal to 0. So T3 will be equal to W, or W is equal to T3. That's it. And the answer is 6.366 newtons. When the answer gets negative, It means the directions of your forces is not the right way. It should be the other way. Okay, because these are all vectors. Did you understand? Very good. Okay, I think putting the thingy enclosure is not, I just have to shade it. There you go. Hooray. We're done. So the other question that I have included in your exam, the other question, it has something to do with friction as well, but it's like this. You have to learn this as well. Try to search for questions like this one. So there are two blocks, block A and block B. And for block B not to go down, there is there is a rod that joins them. So the position should be like that. When the friction is not that much that it cannot hold B, or it cannot control B going down, then of course there's movement. That's already dynamic. So it should not move. It should be like this. So try to find one question like this, please. I'm not going to discuss this anymore. But a clue here is the friction here. For example, going to the right on movement. This is trying to, no, no, no. I'll change my words. A is controlling the block to go down. So the movement will be going down here. So it means that friction should go against. That is friction. There's a normal force here. Now, because this is not a string that is directed like that, that is T1 when you're going to cut it. No, it is inclined this time. The force is inclined. Naintindihan? Okay. The force here is inclined. It could be compressive. It cannot be because this is like a rod, yeah? So this is trying to push your A so that B will go down, but A doesn't like B to go down, so it has to control its movement. So the force will be going to the right. And also, this must go up like that. When it goes up, then your free body diagram will be friction going to the right, normal force going up. You have a weight of the block, and you will have a tension, or, well, a compressive rod. I'll just call this one as a P. Will be going that way. So P will be resolved into its components. You have the Px and you have the Py. So that in the y-axis, you will have Py, you have W, and in the x-axis, you have Px and you have frictional force. So look for a question like this. This is a question I included in the exam as well. But I guess I have completed everything for the first question. It's just that I added one more block here in this example. In the exam, you only have 3 blocks. Okay, so that is already a bonus. I'm just trying to help you out because I know that there are a lot of people or students who failed during the prelims. Okay, I'm going to send this to you now. Thank you so much for watching, and I hope you're all okay wherever you are. And oh dear, I did not. Did I not? Oh, stop the screen. What do you mean stop the screen? Did I not present it? I have talked a lot already. Did I not present it? If I did not present, then oh dear me, that would be a shame. I hope I did. All right, for those who are there, did I present? Oh gosh, can I just look on my video? Hang on. I have to do it all over again if I did not share my screen. That would be silly. and I will discard. I hope I did. Oh, I did. I'm seeing it here. I did. Oh, thank you. I'm gonna. I have to tuck my shoulders. Yeah, I did it. I did it. All right. So if you had seen these explanations here, then you are ready to receive um, the the computations, yeah, the workings. I mean, okay. So yeah, that's it. I'm successful for this video because it's a bit long. I cannot do it again, and it's first hand video. All right then. Bye for now. It's 50.54. Look, it's getting to 51 minutes. I finished it that long. Okay then. Sir Ronald is watching. Yes, Sir Ronald Santiago. Yeah, thank you for watching. You are there. Yes, I'm doing a supplement. If not, I'm lecturing for the statics. Okay, so this is it. The next video I'm going to do is I finished my calculus one face to face already, and then I did differential equations, and then just one question that will come up in the exam. In statics, I did one, and I explained about the second one as well. I've got two more. Fluid mechanics. I think I have to lecture about fluid mechanics as well, but let's see. And then what's the other one? Oh, EDA. I need to lecture on exponential probability. But I still have to eat. Yeah, I am hungry. What time is it? It's 10:51. I need to have a break, man. All right. Bye for now, my dear students. Keep safe. God bless. And I'll see you when I see you. I hope we can see each other within the week. And I hope there will be no more typhoons. Okay. Bye for now. One, two, three, bang.